Now we are going to look at the limit as x goes to 0 of sine of pi over x, and we're going to try to guess the value of this limit by plugging in nearby numbers. So some nearby numbers that we've picked to plug in are a tenth, a hundredth, and 1/10,000th. So if we go ahead and plug those into sine, we are going to get sine of pi over a tenth, which simplifies to sine of 10 pi. And we know that any integer times pi, if you take sine of that, you get 0. So this is going to be 0. And now let's do the same thing for 0.01. We're going to have sine of pi divided by 0.01, which is going to be sine of 100 pi. And again, that's an integer times pi, so sine of that is going to be 0. And we can try again. We can get sine of pi divided by 0.0001. That gives us sine of 10,000 pi, which is again 0. So it seems like we would want to guess that this limit as x goes to 0 of sine of pi over x would equal 0. This is our guess. Maybe we're worried about limits from both sides. So let's try a nearby point that's negative as well, just to be sure. So let's plug in negative 0.0001. Sine of pi divided by negative 0.0001 is sine of negative 10,000 pi, and that's still 0. All right, so I feel even better about it. This limit, I'm estimating that it's 0. Let's go ahead and check the graph, though. Ooh, that's not what I expected at all. So the numbers that we plugged in a bunch of numbers over here. They all happen to give us 0. Plugged in a number over here. It happened to give us 0. But that was just kind of a coincidence, because we could have chosen to plug in numbers that would have all given us 1. We could have chosen to plug in numbers that would all give us -1. And in fact, we could get as close as we want to any number here between -1 and 1. And so for us to have a limit as x goes to 0, it needs to be that as we get closer and closer to x being 0, we get closer and closer to y being a single answer. Here, y gets closer and closer to the whole interval from -1 to 1. And so we say that this limit does not exist because it doesn't have a single unique answer. There's something else that's really important to point out about this example. This shows us that this technique of plugging in nearby numbers is not good enough. Because we can plug in nearby numbers, we can think we have an answer to a limit, but it could actually be that the limit doesn't exist. And that's why in the next section we're actually going to learn something called limit laws. And these are going to be ways that we can find the limit for sure, and we're not just estimating it.